Imagine our solar system, but with a twist. Instead of one Jupiter, picture two gas giants, each a colossal world of swirling clouds and intense gravity. This is not science fiction, but a fascinating thought experiment exploring the implications of a double Jovian system. The existence of two Jupiters would dramatically alter the dynamics of our solar system. Their combined gravitational pull would reshape the orbits of planets, scatter asteroids, and influence the very fabric of our cosmic neighborhood. The presence of two Jupiters would be a testament to the universe's capacity for diversity. It would challenge our understanding of planetary formation and the delicate balance that governs our solar system. We often take the stability of our solar system for granted, but the addition of another Jupiter-like planet would introduce a level of chaos that's hard to fathom. This scenario, while hypothetical for our solar system, is rooted in astronomical observations. We've discovered numerous exoplanetary systems hosting multiple gas giants. These systems provide valuable insights into the potential outcomes of having two Jupiters in close proximity. Studying these distant systems allows us to explore the potential consequences for planetary evolution, habitability, and the search for life beyond Earth. The gravitational dance between two Jupiters would be a sight to behold, but it would come at a cost. The inner planets, including Earth, would experience significant orbital perturbations. Their once stable paths around the Sun would become elongated and unpredictable. The immense gravitational pull of two Jupiters would create a chaotic environment in the solar system. The consequences could be catastrophic. Planetary collisions would be a real possibility. Earth could be flung out of the solar system entirely, becoming a rogue planet adrift in the interstellar void. The survival of our planet, and life itself, would be in jeopardy. It's a sobering thought that highlights the fragility of our existence in the grand cosmic scheme. The stability of the asteroid belt would be shattered. Asteroids, remnants from the early solar system, would be scattered like cosmic shrapnel. Some would be hurled towards the inner planets, posing a constant threat of impact. Others would be ejected from the solar system, adding to the debris field of interstellar space. The once orderly asteroid belt would transform into a chaotic and dangerous region. Beyond the asteroid belt lies the Kuiper Belt, a distant realm of icy bodies. Two Jupiters would dramatically alter the structure of this region. The gravitational influence of the gas giants would scatter Kuiper Belt objects, sending some hurtling towards the inner solar system as comets. These comets, icy remnants from the solar system's formation, would become more frequent visitors to the inner solar system. The increased cometary activity would have both positive and negative consequences. On the one hand, comets are believed to have delivered water and organic molecules to Earth, playing a crucial role in the emergence of life. On the other hand, cometary impacts are known to trigger mass extinctions, reminding us of the destructive power of these celestial wanderers. The presence of two Jupiters would also influence the formation of planets. The gravitational interplay between the gas giants would stir up the protoplanetary disk, the swirling cloud of gas and dust from which planets form. This could lead to the formation of more massive planets in the outer regions of the solar system. The dynamics of planetary formation would be fundamentally different in a two-Jupiter system. The discovery of a double Jovian system in our own backyard would revolutionize our understanding of the universe. It would challenge our preconceived notions about planetary systems and the conditions necessary for life to arise. The existence of such a system would force us to re-evaluate our place in the cosmos. It would demonstrate that our solar system, with its seemingly unique architecture, is just one of countless possibilities in the vast expanse of the universe. The diversity of exoplanetary systems discovered in recent years has already challenged our understanding of planetary formation. A two-Jupiter system would further expand the boundaries of our cosmic imagination. Furthermore, it would raise profound questions about the nature of habitability. Could life exist in a solar system as chaotic as one with two Jupiters? Would the constant threat of asteroid impacts and the volatile orbits of planets make life unsustainable? These questions would fuel scientific inquiry for generations to come. Section 5. Challenges for space exploration, navigating a chaotic solar system. Space exploration in a double Jovian system would be fraught with challenges. The gravitational pull of the two gas giants would make it incredibly difficult to plan and execute missions. Spacecraft trajectories would be constantly affected by the changing gravitational landscape. The precise calculations required for interstellar travel would become exponentially more complex. The increased presence of asteroids and comets would pose a constant threat to spacecraft. Missions to the outer solar system would require advanced shielding and navigation systems to avoid collisions. The dream of human exploration beyond Mars would face formidable obstacles. However, these challenges would also foster innovation. Engineers and scientists would need to develop new technologies and strategies for navigating this chaotic environment. Spacecraft propulsion systems would need to be more efficient and powerful. Autonomous navigation systems would be essential for avoiding collisions. Section 6. The search for exomoons, unveiling the secrets of double Jovian systems. The presence of two Jupiters would also have implications for the search for extraterrestrial life. Gas giants themselves are unlikely to harbor life as we know it. However, their moons could be promising candidates. The gravitational interplay between two Jupiters could create tidal forces that heat the interiors of their moons, potentially creating habitable environments. The search for exomoons, moons orbiting planets outside our solar system, is still in its infancy. However, the discovery of exomoons in a double Jovian system would be a major breakthrough. These moons would offer unique environments for studying the potential for life beyond Earth. The study of exomoons in a double Jovian system would provide valuable insights into the formation and evolution of planetary systems. It would help us understand the factors that contribute to the habitability of moons and the potential for life to arise in unexpected places. Section 7. Life in a double Jovian system, possibilities and challenges. The possibility of life in a double Jovian system is a tantalizing question. While the chaotic nature of such a system might seem detrimental to life, it could also provide unique opportunities. The increased cometary activity could deliver water and organic molecules to otherwise dry and barren worlds. The gravitational interplay between the gas giants could create tidal forces that drive geological activity on their moons, potentially creating habitable environments. However, life in such a system would face significant challenges. The constant threat of asteroid impacts would require any life forms to evolve robust survival mechanisms. The volatile orbits of planets would create extreme seasonal variations, challenging the adaptability of life. Despite the challenges, the possibility of life finding a way to thrive in a double Jovian system is a testament to the resilience and adaptability of nature. It highlights the vast range of environments where life might exist in the universe, challenging our anthropocentric view of habitability. Section 8. Conclusion: Embracing the wonders of a two-Jupiter solar system. The concept of our solar system with two Jupiters, while hypothetical, offers a glimpse into the boundless possibilities of the cosmos. It underscores the delicate balance of gravity that governs planetary motion and the potential for chaos in the universe. While the presence of another Jupiter would undoubtedly pose challenges, it would also unlock a treasure trove of scientific discovery. By studying the dynamics of a double Jovian system, we could gain a deeper understanding of planetary formation, the evolution of solar systems, and the potential for life beyond Earth. It would be a testament to the universe's capacity for surprise and wonder, reminding us that our cosmic backyard is far stranger and more awe-inspiring than we could have ever imagined.